is Tuesday, January the 14th, and I have done a bit of soul searching over the past 12 hours, and by soul searching I mean that yesterday's video took far too long to edit. I was up till 11:30 last night, and I still didn't even get the entire thing done. And for those of you who are like, oh, but in college 11:30 isn't that late, believe me, I know. I just wasn't going to, stay up that late doing something that's really more of a hobby than actual schoolwork. But to be completely honest, the one good thing about the long editing times is actually the editing process does serve as additional studying for me, because I do get to watch myself back in the editing suite explaining all these new concepts. So overall, I'm pretty cautiously optimistic about this entire process. I think it'll work well, if I can keep doing it consistently. So one of the things that I think I'm going to do is, right now, before we jump into the new material that I reviewed today, I'm going to quickly go over the topics that I reviewed yesterday. And I mean, like, lightning fast. We were introduced yesterday to the concept of graphing in 3D space, and we were given an equation to find the distance between 2 points in 3D space, which is the following. D is equal to the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared plus the quantity of z sub 2 minus z sub 1 squared. And of course this is derived from the Pythagorean theorem. Coulomb's law is a force equation that will tell you the force applied on 2 charged particles given their charges and the distance they are from one another. This force is proportional to the product of the 2 charges and inversely proportional to the squared distance. Thus we are given this equation: the charge of the first particle times the charge of the second particle divided by the distance squared, all multiplied times Coulomb's constant. So with that out of the way, let's move on to the new stuff. So today in calc discussion, I learned that you can take an equation with only 2 variables and still plot it on a 3D axis. So for example, in a 2D world, the line x equals... Lights just turned off. The line x equals 5 looks like this. Of course, just a straight line pointing up and down at x equals 5. It encompasses all the points where x is equal to 5. Pretty simple. So in a 3D world, we would start by plotting the line normally. But then we need to realize that this equation doesn't actually specify either y or x coordinates. So what that means is it encompasses all x and y coordinates. So what we get here is a plane that encompasses every single point where x is equal to 5. We can also plot inequalities such as this: y is less than 8. And we start, of course, with a line at y is equal to 8, except it's dotted because this inequality is non-inclusive. Now, the number of points that will fulfill this condition are a lot greater than, say, if y was just equal to 8. Because now, instead of y just being equal to 8, we just need y to be less than 8. So notice now, like before, we have another plane made up of all the other x and z coordinates that are included with y is equal to 8. But since we have an inequality, y is less than 8, this plane extends towards negative infinity, making like a giant loaf of bread. I like to call it the Infiniloaf. It's something you would buy at a space mart. So with that review out of the way, I'm going to do the 10.1 section of my math homework that is due next week to help me prepare for class tomorrow. Posted here are the questions that I'll be doing. Again, if you have Stewart Essential Calculus 2nd edition and want to follow along, you can. I will come back with any problems or discoveries I have discovered or found. So that actually went really well for me. I only had trouble on a couple of things, and there are a couple things that I still need to keep working on. My math professor was kind enough to give us supplemental materials along with the required assignments, so I probably will be doing some of that over the weekend on my own time. Probably not going to record that though. The first thing that I had a little bit of trouble with was completing the square. It's a very, very simple algebra process that I learned how to do early in my high school career, but I had forgotten how to do it, so I needed to look that up to make sure that I knew what I was doing, but once I did, I remembered how to do it. Another thing that I'm having some trouble with is how exactly we restrict 3D objects when we are writing their graphs in equation form. But all of these things I will get down as I practice. My time probably right now will be better spent moving on to my other materials. So, next is statics. The triangle and parallelogram laws are both ways to estimate the resultant force vectors of two combined force vectors. The triangle law is, of course, derived from the parallelogram law. The sine and cosine laws are both ways to find unknown angles and sides of triangles. In statics, we apply them to force vectors. The sine law is this: sine capital A over A is equal to sine capital B over B is equal to sine capital C over C. Each letter signifies angles and sides that are opposite. For example, big A is opposite little a. The cosine law is different. Instead of just being one equation, it's three. The cosine law uses the side that you don't know and sets the equation equal to it. So with that out of the way, let's do some homework, yeah? For some reason, the statics homework still hasn't been posted yet, so I guess it's physics time. Since I had already gone over some physics review at the beginning of this video, I am just going to go straight into doing the physics homework instead. Updates to follow. I swear I'm not doing this on purpose. I have time right now. I would rather get the stuff done now. But me complaining about not being able to do my physics homework will have to wait, because of course I have other classes to attend to. Now today, my public policy class started. I am very, very excited about it. It contains a bunch of topics that I think will be super, super, super interesting to me. But fair warning, they are of a political nature, and if that isn't your thing, I totally understand. Feel free to click off the video, I won't be insulted. But anyway, let's get started. So going over what I learned in class today very, very quickly, there are two different types of citizenship. Legal citizenship is defined in terms of laws and rules and regulations. Ethical citizenship is subscribed its value by the culture that it exists in. It is how people view citizenship. What does citizenship mean to people? Moving on, there are two different types of employees that we are concerned about in this class. The first is the public servant. It is a broad term to describe anyone who works in a job that benefits a community. Public managers, on the other hand, are like public servants, except they take more leadership positions. They run the agencies, they make sure all the cogs are turning, that kind of stuff. It's not very much, I realize, because we did spend most of the class today going over introductions and reviewing the syllabus. But keeping that in mind, I'm going to do the readings that are going to be required for class on Thursday now. I don't think that there's going to be anything that will be particularly challenging to understand, but if there is, I'll let you know. Finished the chapter and it was pretty easy to understand, but I will probably reread it again tomorrow just so I can have it fresh in my mind Thursday. So, I think that's it for today. Huh. It's only day 2.